Okay, in this video we are going to look at question 4 of the November 2018 question paper, which is a functions question. And let's start with that. In the diagram below, the graph of fx, which is given as ax squared, is drawn in the interval for x smaller than 0. The graph of f minus 1 is also drawn with a point p is -6, -12. That is a point on the graph of f, and r is a point on the graph of f minus 1. Okay, so this is part of a parabola here, the f. Obviously, the other part of the parabola will be there, but since I have a restriction on my domain for only negative x values, then I only draw this part of the parabola, and then the reflection of that in the line y is equal to x is then the inverse function given here. Then they say, is f minus 1 a function? Motivate your answer. Okay, now for the more to 1 function, a parabola, just to mention this, the more to 1 function is not, when you get the entire more to 1 function, the inverse of that will not be a function. That is exactly why I break up the domain into two pieces. So that I have two sets of one-to-one functions, of which the inverse will then also be a function. So yes, since this is a restricted domain part of a parabola, the inverse is a function, one-to-one function. So you can just say, and to test for a function, we use the vertical line test. So question 4.1, you can just say, yes, it is a function. It passes the vertical line test. Vertical line test. I just quickly want to mention, to check whether something is a function, I'm going to take a vertical line and draw it across the sketch, and then if the sketch here only cuts the vertical line once at every single place, then if I'm only looking at this part, then that is a function, right? If this entire thing was my function, at some point you see it cuts the vertical lines at two places, then it's not a function. But this is not one function, it's two separate parts. So if I only look at the f minus 1 graph, yes, that does only cut the vertical line once. And then to test for more to 1 and 1 to 1, I do the same thing but with horizontal line. So this is actually also a 1 to 1 function. All right. And that's the purpose of, I just quickly, briefly want to mention that that's the purpose of breaking the parabola, because a parabola is a function, right? There's my parabola, the entire parabola. It is a function, right? Because it passes the vertical line test, but it's not a one-to-one function, because on the horizontal line test, you see there's 2 points of intersection, 2 points of intersection, so it's a more to one function, which means if I reflect this in the line y is equal to x, to place it then there, this is not going to be a function because it was a more to one. If I reflect it, it's going to then essentially place it on the x-axis as a sideways parabola, and then this is not a function anymore, right? That's the problem I have with more to one functions, is when I reflect it in this line, it will produce a non-function, a relation, which I want inverse functions, right? It's important that the inverse is also a function. So what can I do to make this parabola one to one? I can take it there at that turning point and break it into two separate parts, so that this part is a one-to-one function and this part is the one-to-one function. How do I break it like this? I just specify this is the part for x smaller than 0 and this is the part for x bigger than 0, right? So I just put a restriction on the domain. Then the inverse, this part is going to be reflecting in that line. Oh, this parabola is actually going to lie that side, sorry. since it was a negative parabola, the positive parabola will be that one. Okay, the negative parabola will lie here, the inverse function. So this part is going to reflect there. See, this part reflecting in that line is going to reflect there. And this part here is going to reflect there when I reflect in that line. Okay, so if this is my function, this is my function, this part is then the inverse of only that part, which this is a function, so I can work with this, but the entire thing not a function. So this part is a function and that part of the inverse is a function, so I break it into two separate ones, which then will have this inverse function. Because of the restriction on the domain in the function, the inverse function will have a restriction in the range, right? Because the x and the y swapped from function to inverse. So if the function had the restriction x must be smaller than 1, the inverse function, smaller than 0, the inverse function will have the restriction y smaller than 0. Same there, the function had x is bigger or equal to 0, so the inverse function will have a restriction y is bigger or equal to 0. Okay, so this is more to one functions is, and then obviously in this sketch the part that I have here is this part, right? They did not look at this part, so they only looked at this part of the parabola with that inverse function. And then is this inverse function a function? Yes, because it passes the vertical line test. If R is the point of reflection of P in the line y is equal to x, write down the coordinates of R. So basically, R is the point of reflection in the reflection of the line y is equal to x. Y is equal to x. This line here is the reflective line between the function and its inverse. So if this is the reflection in that line, then it's basically the reflection that has that's connected to the point P, which reflective points will just have x and y values that are swapped. So since P is the point -6, -12, R is going to be the point -12, -6. So just swap the x and y values of that point P to get the values of the coordinates of R. 4.3, calculate the value of A. A is that ax squared, so this point -6, -12 lies on the graph, so I can use that. The equation of f is given as ax squared, and the point -6, -12 lies on f, so I can substitute that into f equation. Then I have -6 squared, so this is 36, -12 is 36a, and then if I divide by 36 I get a third, negative a third. I'm just going to double check that quickly. -12 over 36 is going to be negative a third. Alright, so A is negative a third. 4.4, last question for this video, is write down the equation of f minus 1, the inverse, in the form y is equal to. You should always do that even if they don't tell you anyways. Right, so if the equation is y is equal to x squared, the equation of f is a, which is negative a third, let's not put that in, negative a third x squared for x smaller or equal to 0. Right, to get the inverse function, what I'm going to do is I'm going to swap the x and y. So this is going to be x is equal to negative a third y squared for y is smaller or equal than 0, right? So I will have the same restriction, but now for y in this function. And then, well, let's divide by negative a half on the other side. Then I get negative 2x is y squared. Right. Yes, and then I want to just take the square root both sides, so y is equal to plus or minus the square root of negative 2x x. Okay, and since the y should be negative, since the y value is negative, the function is just f minus 1x, is just the negative root, not the positive one, just the negative one, negative root negative 2x, right? Now, this seems weird for you maybe, that I have a negative under the square root, but remember, if you look at this sketch here where your f minus 1 lies, it lies on the negative x-axis, which means all of the functions that, of all of the values that you're going to substitute into this function of x, all of them will be negative since it's on the negative x-axis. So negative 1, negative 2, negative 3 will produce values where 1, 2, 3 should produce errors because of the negative under the square root, which means there's no graph that side, which is true. The graph does lie completely on this side here. So, yeah, considering that, then the negative under the square root there is okay. It's fine because my x's are all going to be negative anyways. Okay, so there's my equation in the form. And that is question 4. I'll see you in the next video for question 5.